Okay, I'm doing a heat bed test. I'm using RAMPS now, where it was using Sangalulu control board. I do not have the hot end connected while I'm doing this test, but everything else is connected. As you see, the display unit is connected. I have here what is known as a solid state relay, DC, and that's to control the heater, the heat bed. So it's coming out the ramps, going in here, and this is switching the heat bed on and off, and that's on 24 volt power supply. It's a big silver box there. Let me just see part of it. It's very awkward for me, this, extremely. This box here. So that's 24 volts. It's about 500 watts, 480 watts, this power supply. And that's getting reduced to 12 volts using this. It's like basically for a car, I believe. And it knocks down 24 volts down to 12 volts. So this is going into the ramps and powering the ramps. It's going through a fuse, like a car fuse. There, the recommended one. And I've already been trying this out a bit and it works quite well. This does get a little bit warm, but then these are probably meant to be fastened to the body of a car to help keep them cool. But I might, depending how warm it gets, in possibly later test, fit this very small 25mm fan inside with a hole in, etc, etc, to let the air in and out, using the 12 volts from the unit. It is recommended in a way to wire up the yellow wire on here, because that is a higher ampage. There is a red wire coming out as well. That is a lower ampage, I believe. That works well, apart from, for my liking, it did get a bit warm when I tried it the other day when I was using the ramps. I'm going to do another test on that a bit later. But basically I'm going to show you the heat bed now, and it does work. So I've got frontal face open with my board. Now this fan and this power supply does make a little bit of noise actually, and I'll probably look at replacing that later. Be careful if you're opening up these, because one problem with these is they are mains voltage. There's mains voltage going on these three terminals, in this case on the right hand side there, and the only protection really is this plastic thing that goes over the top. It's easy, well, it would be quite easy to touch those contacts in there. So as you see there, it's alright, it's not plugged in at the moment. So you've got your mains voltage, and then you've got three terminals, I think it is, for minus, and three for the positive 24 volts. You do have a trim pot on the corner there for a bit of adjustment, and an LED. I do have my Vinci VC99, and this is just on the heat bed. So we've got, what have I got here? I've got two aluminium sheets. That's below the heat bed in a way, and they're stuck together with some various materials. I'll talk about that in my other video. There's a piece of cork on that, glued to that, about 1mm thick. Then there's a piece of, at the moment, a piece of cardboard which is cut out to the shapes for the wires for the heat bed. Heat bed on top of that with an aluminium sheet, because that heat bed sticks to an aluminium sheet, 2mm thick. And this is a piece of Teflon, I think it is. I'll put the details. I can't really remember. It's like printed circuit board, about 5mm thick. That's held on with these screws. So this cardboard, I might actually remove that and put something sort of rubbery in there so I can adjust these screws for leveling the height. Although it does have nail nuts underneath, but they're extremely difficult to reach. I do have some bigger size nail nuts to come on order. So I'm just trying to fill you in what's happening. This does work, it does get warm, it does stabilise at the voltage. You have to make sure that when you're putting a solid state relay, make sure you do get a DC one, because there are AC ones that switch AC, and those won't be any good. You need one that will actually switch DC, double check that it will, in my opinion. This is a 25 amp, I think this one is. Oops, it does have this cover on it to come off there, just to protect. Solid state relay, it's got number 25 on there, so I'm assuming that's 25 amp. I do have it fastened to this old Pentium 4, I think it is, heatsink, quite an old one I had, because these can get warm, because I've got to take quite a bit of power through them, quite a bit of wattage. 300 watt heater I'm using. Everything seems to work on the control if I use the controls. I'm a bit unsure about how to set the temperature on there, so I'm going to be using pointer face to do it. Alright, I'll plug it in just now, so that's just to give you an insight into how things are wired up. I will put a circuit here. So here is the circuit diagram I am using. First of all, we have a 24 volt 20 amp power supply unit. Then there is the 300 watt 24 volt heat pad, and that is powered from the 24 volts, but it is switched via the solid state relay. The solid state relay is triggered off 12 volts from the RAMPS. Solid state relay, and this is triggered from 12 volts via the RAMPS, but it controls the 24 volt power supply going to the 300 watt heater. Now make sure that you do get a DC solid state relay. That is one that can switch DCs, direct current that is. This is the buck converter, that is, it reduces 24 volts down to 12 volts, and that is what is going to power the RAMPS. So we're getting 24 volts from the power supply unit, the same power supply unit that is powering the 24 volt heater, and we're reducing that down to 12 volts, which is powering the RAMPS. This 12 volts also controls the solid state relay, powers the 3D printer on normal 12 volts, just as a normal 12 volt input would. So this is the voltage reduction I am using. A lot of this is in foreign. We'll put the circuit diagram on here. Okay, just make a box like this. It uses this aluminium case as a heat sink because it has MOSFETs or ICs bolted to it. One there, that one there inside. Now, when I was using this earlier, I haven't done a definitive test yet. This was getting warm, so I may hack it open and fit this small fan in. I think it's going to get a bit too warm, because these are really meant for probably fastening to a car body, which would take away the heat a lot. Basically, we've got, when you get it, you've got 3 wires sort of going in on the left, yellow, black, red. 3 wires coming out on the right, yellow, black and red as well. Now, as you see, hopefully you can see there, oh there it is, it's recommended that you do fit a fuse, 30 amp fuse it recommends, that will be the maximum. So I have this inline car fuse, it's waterproof, just like a, very tight this. Actually, I don't know if I can get that out. Extremely tight. Anyway, that plastic, that fuse can almost plug in there or unplug, or should be able to. It's supposed to be water protected, this inline fuse. So basically the power scheme is almost going, well it is actually going, not almost, it's going 24 volts coming to the fuse, inline fuse there, it's going through to 24 volts, and that's going to the yellow input. That is the yellow input, because the yellow input, well the yellow wire, you'll see that is a bit thicker than the red wire, is a higher ampage. That is the full ampage of this, that's 30 amps I reckon. Seems a lot actually for that wire, but that's what they're stating. And one reason I get a higher ampage, well rated ampage units of just about anything I buy on eBay, because I tend to be very optimistic on eBay. So I tend to try and double it if I can, the ampage rating that they say. The red wire here is not used at all. So we've got black, that's the ground going to the power supply coming in. And in a way we've got red going through the car fuse in this case, going to the yellow. So that is the input, and the output we've got black, which is going to the negative, and that's going through this wire to the ramps. And we've got yellow coming out, that's going to the positive of the ramps. The red wire again is not used. That is basically that. On the ramps board, so on the ramps we've got the 2 wires coming in, positive and negative. Make sure you get the polarity correct. But then all I've got is a small loop of wire here, going from the 5 amp to the 11 amp. So it's coming in, say the positive, going to the 5 amp, but the same connection is going to the 11 amp rated input on the ramps. Same with the negative, just like a Y connection, both connected to the output of this 24 volt to 12 volt step down converter unit. Okay, let's plug it in. Now expect a bit of noise here. Excuse me, a bit of cold. Right. I'll show you the, let me turn that Vinci VC99 on. Press the button so that it won't go to automatic off. So that's saying, yes, you can see that 24 on the Vinci. Let's see, got a bit of glare on the actual thing. Display there, and turn it about. We've got 26 on there as well. Okay, now at the moment it's not even connected, so I'm going to connect. And I'm going to actually tell it to do, well, set it to off to start off with. That's a heat bed, so the heat bed is turned off. Now basically there's no temperature at all there, just the ambient temperature, so that's set to off. And it's about 26 odd degrees, 24 it's saying on the Vinci. Okay, let me zoom out a little bit, because this does have an LED on this solid state, tell you when the power's going to it. It does have a LED on the ramps. I'll try to show you that as well, that'll come on. Let me set this to a low thing, about 35 degrees. I'm going to click on set. 5, 4, 3, 2, 1. Clicked on it now. And you might even hear it. You hear a noise there. Let me move over, because then I can show you the LEDs. So there's the LED on the solid state relay telling you that it's getting the power, and here's the LED on the RAMPS board down here. Now when I tried this earlier, all the MOSFETs were, just let me check again, cool, and we see that's gone out. So basically it's switching it on and off at that temperature, which is set to, so it's only set to 35 degrees there. That's quite a low temperature, so that's one reason it's switching off quite quick there. We're saying 35 here at the bottom and 35 at the top. So the one at the top is like the target temperature on this display. Right. So, and the one at the bottom is the actual temperature now. So I'll probably switch back on just now because it's gone. Yes, I can hear the difference. And then it's switched off. I can hear the actual fan, which is a bit noisy on this power supply. That's the power supply fan down there, around here. That's building up speed, and it's taking that little bit more like power out. Okay, so that's stabilising that. Well, it'll take a bit to actually warm up because of the thickness of the plates. It's like that's what I would say, just like average warm, just slightly warmer than actual real life ambient. Let me put this on. Hopefully you can see that that is 33, 32. Okay, let's set the temperature to something like 60 degrees, which is PLA setting in this case for the heat bed. Now it takes a bit before it starts. There, it's starting now, I can heat it. So we can see that I've set it to 60 in the display. That's the one above, and that is 40 degrees give or take now it's saying on this. So this is the actual temperature of the thermostat, thermistor I should say. It's a proper word I believe. And the Vinci VC99 is almost showing the actual surface temperature of the heat bed. Now this is just like a hamster ball with a spanner on to hold the thermostat where it is of the Vinci VC99 onto the heat bed. Now that is certainly getting what I would term as lukewarm. The LED is still on, so it's still getting power there. Let me try and move over quickly. So you can see the two LEDs, one on the RAMPS board and the one on the solid state. So it's on 56 at the moment on the display. We'll get all this in together. Awkward. And just see how that's gone off. That's gone off as well because it's reached a temperature, and you probably heard the power supply fan, which is far too noisy in my book. But if it does the job, it does the job. So it's switched off there. The Vinci VC99 is saying 39. So there's quite a discrepancy between the actual surface bed temperature and the thermostat. Remember now it's going through this 5mm thick Teflon, I think it is. That's the name of it. I'll put the details on this video. That is getting pretty warm now. Hotter than lukewarm certainly. Let me check these MOSFETs. Cool. No heat at all on any of the MOSFETs. And that's one advantage of switching through this solid state relay, is that basically you can switch almost, well, really high levels of power through a solid state relay. I'm a bit unsure about pulse width modulation on a solid state relay, whether it could handle the speed of such things. But generally on a situation like this, I don't think you're going to need that a lot. So I'm just letting that stabilise. It's on front or face. I'm asking for front or face, asking for 60. And the display is giving us 60. So it just switched on there, you probably heard it there, and it's raised it to 61. It's turned itself off now. Yep, the lights are off, and now it'll start cooling down. When it gets up, I think it's 59, but you can do a lot of adjustments in the software. The settings, so to speak, to allow for such things, and even probably to allow for the thickness of my heat bed here and the heat that will take to warm up. Remembering that the Vinci VC99, I have found it to be a bit unreliable before, but I'm a bit unsure about that. That is taking the surface of this, and it's going to take a bit of heat actually to warm this bowl up and this spanner up a bit, which is basically just on the other side of this thermostat on this heat bed. That is pretty warm, so I'm going to knock it up to 100 and 110 I think it is on, oops, 110 ABS. That is what it's suggesting in front of us. Clicking set now. So I've clicked set and the lights have come on. I don't know if you'll be able to see them from this angle. But there's 110 displaying there, asking for, and it's at the moment about 64, 65 and gradually rising. So let's have a look at front of face. So you see the graph is gradually ramping up, asking for 110 there. The LEDs are on. Let's see about this. I don't know, yeah, you might just see a bit of a glow on that. You can't really see it on the ramps from this angle. You take my word for it, the LEDs are on, so it's getting the power from the ramps board, telling the solid state relay to turn on and off, and that is controlling the 300 watt heat bed that I am using under this. And that is getting very hot now. Almost too hot to touch really. Well, finding length of time anyway. Now, one thing about my setup anyway, it will take some time. It takes approximately half an hour to cool down from a high temperature like this, 100 and odd. I'm just going to leave this a few seconds. The LEDs are on, so it's still getting power. You're on 91, 92, that is the temperature. So it's saying 94 and we're asking it to go to 110. I can see a bit, I don't know if it's the angle I'm looking at or what it is, but I can certainly see a bit of flicker in this camera display. It's not actually in real life. On this like white bar going across, there seems to be a bit of a flicker there. I presume that's to do with the camera's strobe and the actual how many times it's taking a shot per second, or how many frames per second the camera's running at. So it's saying 100, and let me move over so we can see the LEDs once more. So again, let me try and get the, sorry about this, yeah, let me zoom out a bit. You're right. Move that over, so probably see the red LED there. Now there's a lot of strobing on there, that's nice. In real life there's no strobing on this, it's solid, that display. So we just see the red LED down there. 106. Once it gets to 111 it should certainly stop. And we listen for that on the fan as well. One advantage of having noises. And there we go, it's, the lights, LEDs have gone off. So the power to the solid state relay is switched off, and that has switched off the power going to the 300 watt heater, 24 volts. and switch back on now. So it's 12 volts coming in here, direct from the RAMPS board. As I say, I'll put the circuit diagrams here. This is quite effective, no problems. I'll say, just stress again that it is important that you put the, like what the term as a positive wire, that is going direct to the positive of the power supply, coming out there, going in here, and then it's sort of switching through this, going to the heater, coming back through negative. Okay, if you swap those about, it won't work properly, even though you might think it like a normal switch obviously would. In this case, I don't think it will. As I say, this one has a plastic cover on. That's it without. I'll put the details down below. Let me see if this is getting warm. If it is, it's very slight. Can't really feel it. Remembering that this is going to be, as it is now, probably switching, once it gets to the power, it's probably going to be switching on and off quite a bit. But even so, I would certainly recommend having some sort of heat sink on these. Let me have a feel of this. Like a buck converter basically, to knock down 24 volts to 12 volts to power the RAMPS. So this one is going into the power supply of the RAMPS, and then like two wires going from the 5 amp to the 11 amp. They're just like looped together with a small bit of wire there. Anyway, I'll put, as I say, the circuit diagram here. So let's see, that is saying 109. Actual surface temperature according by the Vichy VC99, which I have known it seemed to be about 5 degrees out before, is saying, well, about 90. There's my thermostat on the bed. Now I do have a test program which I'm going to run, which will move all the axes about 100 millimeters, 100 millimeters. I think that also turns a hotbed. Well, I know for a fact it turns a hotbed on and off, and I imagine it might turn the heat hot end on and off, and it does the feed, it does all the actions basically. It's just a test program. I'll put a link on that on this video. Be careful about using that, because if you, I don't know how it does the feed on that. I don't know if it turns a heater on for the hot end and then tries to feed it so many, and it might do forward and backwards as well. So I'll talk about that in a different video. I'll just finish off with that. Just going to turn this off now. Let's have a look at the temperatures. So I'm asking for 110, and according by software it's given 109. According by the VC99 it's only 88. But that is the surface temperature. Yep, even this tin here is getting pretty warm now. Spanner's getting slightly warm. That's just to weigh it down. Keep that thermostat on there. So that seems okay for the heat bed. And I'll just show you that front of face. And if you listen, you can probably hear it switching on and off. So you can see the graph is stabilised, well, reasonably stable. Now, as I say, this can take a good half hour to cool down. This is very hot, this. I can touch it, but sting my fingers even if I tap it like that. This is, just finish off now, just say that this is hardly any heat at the moment, but then we're not actually using the ramps a lot. We're not using it to go through any stepper movements, which the software will do. That's one reason I want to test that. Okay.